Hi everybody. As I mentioned at the end of the last section, section 11.2 is about inference about two means now instead of population proportions. And again, this material will be broken down into two sections. So in 11.2 we'll talk about dependent samples, and then 11.3 we will talk about independent samples for two means. So again, remember in this case we're talking about means again, so just as in the last chapter, chapter 10, we will be using the t statistic in this case rather than the t distribution rather than the normal distribution. So the objectives in this section will be to test the hypothesis regarding matched pair data, again because we're talking about dependent samples, and then we will construct and interpret confidence intervals about the population mean difference for matched pair data. So let's look at objective 1. So objective 1 is about testing a hypothesis regarding matched pair data. So in other words, statistical inference methods on matched pair data use the same methods as inference on a single population mean, except that the differences are analyzed, right? And so another way of saying that is I guess you could kind of do this like we did in the last section. You could have mu1 is equal to mu2, but we're just going to look at the difference in this case. So as far as the steps in this case for dependent samples regarding the mean, again the procedure for this is outlined on the bottom of page 544 and the top of page 545. So essentially the steps I'm about to show you are what's in that purple box on those pages. One thing again we'll have to be sure about is in order to use this test, again certain things have to be true, right? So again in most cases I'm not going to have you verify this, or if I say verify all the conditions are met or satisfied, right, you can ignore this. But just to talk about this again, so the sample again has to be simple random sample. The sample data have to be matched pairs. The differences in this case are normally distributed with no outliers, or the sample size is large. So in other words, n has to be greater than 30, because remember in that case you can essentially use the normal distribution anyway. And the sample values are independent. So in this case, in the last condition, I guess, also means that the sample size is no more than 5% of the entire population size. So step 1, again, we'll have three possible tests in this case. Remember, we're looking at the difference, so you can basically think of this as meaning that mu1 is equal to mu2, or the difference between them is equal to 0. Right, and same things over here. And then again, the level of significance alpha should be given to you again, and as usual, if it's not given to you, you can assume that it's 5%. So in this case, the test statistic will be the average of the difference of the data. So that's what this is, divided by the standard deviation of the difference divided by the square root of the sample size. And again, remember the t distribution, just as in chapter 10, depends on the degrees of freedom. So keep that in mind when you're calculating this. And then again, once you've calculated this test statistic, you can either compare z-values using the classical approach, again either using table 6 or StatCrunch or some other software. And again, you'll have two-tail, left tail, and right tail just as before. And again, if the test statistic falls in the critical region, you reject the null hypothesis. If not, you do not reject the null hypothesis. Or if you use the p-value approach, you're comparing the exact areas rather than the z-scores. The exact areas are the probability. Again, you can use table 6 to determine that, or again, you can use technology. And again, the step-by-step for that is given on page 553, the bottom of page 553 and 554 in your book. It should explain how to, use your TI-83, Minitab, Excel, or StatCrunch. So if you guys have trouble with that, let me know. And again, if the p-value again is less than alpha, just as before, we reject the null hypothesis. And then again, don't forget to state the conclusions in words that somebody who maybe hasn't had statistics can understand. So one thing to just be aware of is these procedures are not robust, which means that if the data basically isn't normal, it can adversely affect the results. However, if the data has outliers, the procedure, even if it is relatively normal, if there's outliers, you shouldn't use this. And again, we'll talk about non-parametric tests or other tests you can use in Chapter 15, or we will if we have time to get there. So as an example, let's look at the following data here. So the data I'm going to give you here in a minute shows the cost of one-night stay in Hampton Inn Hotel and La Quinta Inn hotels for a random sample of 10 cities. Test the claim that the Hampton Inn hotels are priced differently than the Quinta hotels at the 0.05 level of significance. So in this case, because the cities come from the same town, there's a dependency between them. So this would be sort of match pair dependent data. So here's the prices for the same two cities. So in Dallas, right, you have the Hampton Inn price here, La Quinta Inn price here is slightly lower. So in some cases the Hampton Inn price is more, in other cases like in San Diego the La Quinta Inn and Suites price is more, right? It all kind of depends on the city. Generally it would seem like the Hampton Inn prices though are more expensive. So, but the question is there a difference? So remember, we need to look at the difference between these two data sets, not the actual value here. So we'll compute the difference between these. So the difference between this price and this price is 24. The difference between this price and this price, for example, would be 53. So calculate the differences. Calculate the average of those and the standard deviation. You know, at this point, I will probably not have you calculate this at this point on the exam because you know, it is a little time consuming to compute this, at least by hand. And since I'm not requiring that you use StatCrunch or something, you know, I'll probably give this data to you, but just to let you know where this is coming from. But on the homework and things, you might need to compute some of these values from scratch because you will have access to StatCrunch on the homework. And then again, you need to test for normality. Again, you know, this condition will normally be met. You know, I will give you a QQ plot like this. So that you don't have to really do the test. You know, I haven't really had you do this in previous examples, and they will give you this on, I think, in most of the homework problems. So not really anything you'll really have to worry about. But and you know, on the homework or exams, in real life though, this would be something you'd have to worry about. And then again, box plot to make sure there are no outliers, and then set up your hypothesis test. So we want to determine, is there a difference in price? Again, this was the level of significance you're given, so plugging all that information into the table here, or into the formula, you will get this. And then again, remember the t distribution will depend on the degrees of freedom. So again, you can use the classical approach where you're comparing the t2 value, the 2t value. Since this is a two-tailed test, the critical regions then would be determined by alpha over 2. And then again, you can compare the t values directly, or if you want to use the p-value approach, you would compare the areas directly, or again the probability, because the area and the probability are the same thing. Since the p-value in this case is less than the level of significance, we reject the null hypothesis. And remember, you'll need to double the area here because you're talking about a two-tailed test, and since the t distribution is symmetric, you can just double it, unlike the chi-squared distribution. And then again, make sure that you state the conclusion again in words that people can understand. So there is sufficient evidence to conclude that the Hampton Inn hotels and the Quinta Inn hotels are priced differently. Now, the thing about the way this test is worded, it won't tell you necessarily again which hotel is priced higher. Right? You'd have to use the left-tailed test or right-tailed test to determine that. But I would assume it's the Hampton Inn. But anyway, so you can't necessarily draw that conclusion from the data. So there's an example. Now the second thing we might want to do in this case is construct a confidence interval, just like we did in the chapter 10. So again, this is the formula for the sample, or for the constructing the interval. So again, you've got the mean of the difference times, or plus or minus t over the alpha over 2 times, again, the standard deviation of the difference divided by the sample size. And again, just remember that the t-values in this case are, again, using n minus 1, the number of samples, minus 1 degrees of freedom. just note in this case the interval is exact when the population is normally distributed and approximately correct for non-normal populations, again provided that n is large, greater than 30 or something like that. So here's an example. So let's say we wanted to construct a 90% confidence interval for the mean difference in price between the Hampton Inn versus La Quinta hotel rooms using the data that we had before. So we remember that we calculated the mean of the difference and the standard deviation. And then again, you can either use a table or StatCrunch to calculate the confidence interval. But in this case, the alpha level would be 10% because we've got a 90% confidence interval. Remember, you need to divide that by 2. So you'd want to look at t of 0.05, t of 5%, for 9 degrees of freedom, and that would be your t alpha over 2 value. So just multiply that times the standard deviation of the difference divided by the square root of the sample size. So again, it might be easier to just compute this and then take 51.4 minus this number plus this number, and this is your confidence interval. So in other words, you could be 90% confidence that the mean difference in hotel rooms for price for a I think this is supposed to be Hampton Inn, right, not Ramada, versus La Quinta Inns is between $33.53 and $69.27. All right, well that wraps up section 11.2 on dependent samples. So like I said, the next thing we'll talk about is inference about two means regarding independent samples. In that case, we will still use the t-table, but the test statistic will be computed slightly differently. So, all right, so again, I hope that makes sense. Again, if you guys have any questions or anything as usual, make sure you contact me.